That's wonderful. All right. Today we are showing you how to future-proof your next design with a flexible footprint. And I'm joined today by two of my favorite employees at Advanced Assembly, Shane Sheffield and Sebastian Weber. Shane is the Executive Vice President, and he has been with Advanced Assembly since just about the beginning. Shane, tell us a little bit about yourself, buddy.
Well, first of all, Bark, you introduced us as um, technical, and that would not be the word I would use to describe me. But I do come from the sales side. So my name is Shane Sheffield, and I'm the Executive Vice President here at Advanced Assembly. I've been here for almost 15 years. When I started here, Advanced Assembly was only about a year old. So in my time here, I've had the fortune to do a lot of different jobs within Advanced Assembly. I think pretty much every job at one point or another I've done, run machines and place parts on boards. But fortunately, with a lot of growth over the years, the company just stuck me purely in sales, and so the quality of the PCBs that we were building went way up when that happened. They finally locked me down in a corner somewhere. But so I've been in sales, but here at Advanced Assembly for almost 15 years. Now, in that 15 years, what we've done at Advanced Assembly is we don't just sell stuff. We spend a lot of our time trying to help our customers solve problems. For instance, 15 years ago, when I started, the idea that we would even try to place an 0402 on a board was unheard of. We told customers that we just couldn't place a part that small. But customers kept asking for it. And so eventually we figured out that we had to find a way to service that need. And we went and serviced, found a way to place those components. And then, a few years later, then it was 0201s, and the same thing repeated itself. Enough people asked for it, and we went out and got them the equipment to place 0201s, and then we thought that would be the smallest we would ever go. We're not going to go smaller, and dang it if 01, 05s didn't come out later, and so as our customers had those requests, we went out and we found a way to place those too. The point I'm trying to make is, here at Advanced Assembly, from the very beginning, we've always tried to focus on meeting the customer's needs. But today we're going to do something a little bit different. Today, what we're going to do is we're going to talk about a way to, as Mark mentioned earlier, to future-proof your prototypes and new designs against the shortages that everybody is experiencing, specifically in the passive components. So that's a little bit about me, and then I can kind of tell you how we came up with this idea, and then I'll let Sebastian introduce himself. But how we got to this point that we are today is I was sitting with a customer, a longtime customer of ours, named Mike Drake. Like to give him a lot of credit for this, but he was having a tough time building some boards that he couldn't find the parts for. We talked about quite a few options. Different ways for him to increase his selection without really it impacting his board too much. We came up with the idea, and we thought maybe it would work. So we decided that we would try to get creative with the footprints that we were using. So he designed what we're going to talk about today, and then my team here verified it and tested it. And so that's what we're going to be sharing with you today from my side.
All right. Thanks so much, Shane. And just, I know I don't want to go too long, but you're not just the sales manager. You also mountain climb and own a gym, right?
Yeah. Yep. I love the outdoors. And so, yeah, that's just a hobby that I've had for years and years. And one of the reasons I live in Colorado.
All right. Well, maybe if we get a little time, we can hear more about that. Next up, we've got Sebastian Weber. Sebastian is a process engineer too. That's right. He works so hard, it's like there's two of him. Sebastian, tell us a little bit about yourself.
Oh, I'm sure some people wish there was two of me.
Or like half of you.
Yeah, or half. It could go both ways. Yeah. So I'm a process engineer. I am one of the senior process engineers here. My main focus is just improving production processes, either by equipment or identifying new techniques or methods. training people out on the floor, getting everyone on the same page, looking for better materials. I also do a lot of troubleshooting of assembly issues on live jobs for customers and providing feedback to improve manufacturability. I know a lot of our customers like to hear that. I also love to go out there and take our equipment and break it all down to see how it works, how we can make it better. Which most of the time we can't, because these guys know what they're doing, but still good to know what it does, how it does, and all that. And of course, if you ever have any questions, I'm always available to talk assembly and provide you with some information on manufacturability or whether a design is good to go through, if there's a way to make it cheaper, so on and so forth. Yeah, and that's pretty much what I do. I don't own a gym. I do brew beer, which is, in my opinion, way cooler, but yeah, that's basically it.
Well, one of the things that has always impressed me about you, Sebastian, is no matter how many times you take a machine apart and put it back together, you always end up with spare parts.
I absolutely love that. It's a nice
great.
little perk.
Yeah, I don't know what we do with them all, but it's always nice knowing that we have extras.
At some point, we start throwing them away just because we have too many of the same thing. We're just like, I don't know where these keep coming from, but also the machine 4 is down. If you guys could contact the manufacturers.
All right, buddy. Well, let's go and get going into this. As we go through here, I'm just going to mostly host and mediate, and we're going to let Sebastian and Shane do most of the talking. But we're going to present to you the problem, which is the part shortage, a little bit of background and vocab, just so we all have a common language that we can use. Then we'll show you the solution, and finally, we'll finish up introducing a couple potential problems you might run into using this. After that, we'll take questions, but we'll take questions the whole time. Just run them into the Q&A, and if it's appropriate, I'll hop in there and ask them, and if it's not, I'll hold them till the end. So with that, Sebastian, man, you're up.
Yeah. So let's talk about package size, and I'm not talking about that type of package size. That is not a presentation that's safe for work. I'm talking about EIA versus metric. And so you can see on this screen, we have two different parts here. There we go. Let's pop up some stuff.
I'll hold off on that one.
Yeah, one of the most important things to take into account is that there are two different kind of ways to measure package size, and that's EIA and that's metric. Oftentimes, most engineers will use EIA. However, there are some that do use metric. And again, this is kind of the same issue that everyone has had in the entire world, where do you use miles? Do you use kilometers? Do you use, grams? Do you use, it's literally rinse and repeat just for the electronics industry. The biggest issue with this is some of these overlap a lot. So for example, if you look on this right-hand side here, you can see that an 0201 in Imperial is the same size or listed as the same as an 0603 in metric. So sometimes when a customer says, oh, I need an 0201 part, someone goes to source that, they are searching for an 0201 and somehow they end up getting an 0603 or vice versa. And that causes all kinds of issues for production, causes holds. Usually they're pretty quick and easy, but with part shortages, paying attention to that up front can be really, really, really important. So that's something to keep in mind as we go through this. We're going to be specifically talking about EIA. If you look at these part numbers down on the bottom, MA0201 XF104K100 and C1608 X7R1 E104M080AA. While you can kind of identify the package size listed in the part number, those package sizes are actually completely different, right? So it's important whenever you're looking at these that you're checking your data sheets, you're checking, oftentimes the vendor website will tell you whether it's EIA or metric, and that you're aware of what size that part actually is.
Okay, and just to reiterate, we're just sticking with EIA through all this.
Yep.
Okay, sounds great, man.
Yeah, so let's talk, let's get some definitions out of the way. So before we dive in, let's just take a moment to talk about some of the vocabulary. Engineers often use the terms footprint and land pattern interchangeably. Most of the time it's fine since each footprint is usually assigned a unique land pattern, but footprint and land pattern do describe two different things. Basically, the end goal is to get solder to join the metal surfaces on the part and the metal surfaces on the board. That's how you get your electrical connection. That's how everything works. It's just the end goal. The metallized surfaces on the PCB are called land pads, and they're usually arranged in a land pattern for that particular part or type of part. The footprint is the outline of the part. They're both very close in size to one another, but the land pattern is usually just a tad larger to accommodate a solder fillet, which we'll kind of explain further. Again, if you have the part down there, and in some cases this is true, but for chip components and what we're specifically talking about here, mostly passives, you want that a little larger so you can make a nice fillet between your part and your board so you have good mechanical stability as well as electrical connection.
What about the courtyard? What's that?
Yeah, so the courtyard is kind of like your keep out area for your part. Obviously, courtyards are very important for a couple of reasons. The big one is you need to understand what your board fab house tolerances are, because that can affect how large or small those land patterns end up or those traces. And then whatever that tolerance is could potentially stack over during the assembly side. When we go to place parts, if you have your courtyard too small and you have parts too cramped together, you run the risk of them colliding during the pick and place process. You also run the risk of shorts during the reflow process if the pads are too close and the paste finds its way over to the other side. So courtyard is also very important. If you have a really dense design, that's something to pay attention to. If you don't have a dense design and you got a lot of real estate, then it's usually less of an issue.
All right. And sorry about the flipping on the images there so quickly. I was trying to bring up a highlighter so we could share stuff, but it's being persnickety.
Alrighty. Yeah, let's get those pictures in action. So what we can see here is actually some parts being reflowed, which if you're not familiar with the process, we throw paste down onto a bare board, throw that component on, put it in a giant pizza oven, and watch everything melt and weld together. So when solder liquefies, it creates a strong attractive force between the part pad and the land pad. If the other pads haven't had a chance to melt yet, that unbalanced force can cause the part to rotate into a tombstone or a billboard. What that basically means is if you have a side that is more thermally challenging and you're not evenly distributing your thermal mass, what can happen is one side of the pad will melt first and it will cause the part to lift. This is far more common on smaller parts, 0402 and smaller. The bigger parts, 1210s, those types of things usually don't have this issue, but it can still happen if there's enough paste. Let's see, go to the next slide. All right, so, and again, I kind of touched on it earlier, but the land pads are typically larger than the size of the pads on the part. The reason for that is to allow for a really good solder fillet. And you want that solder fillet for a couple of reasons. You want good, strong mechanical connection, and you want a good electrical connection, because if it doesn't have electrical connection, it's just not going to work. And if it doesn't have a strong mechanical connection, it could fail later on. If the part overheats, if the board overheats, if there's some sort of warpage, someone drops it, someone's testing it, and they get frustrated and throw it, it could possibly no longer function. So to allow for a good solder fillet, it's usually designed to be a little larger. And for class 3 assembly, ideally, you want to have that solder fillet climb up at least 25% of the height of the vertical end cap of the component. And that's, again, just to allow for good mechanical stability and electrical connection. You may or may not know this, but the process of putting paste and parts down you put your paste down first, and then you put your parts on top of that. You want your paste to be touching those end caps to prevent them from tombstoning, like I mentioned earlier. So your part will actually sit on top of the solder itself, and during reflow, it will lift it slightly higher up. This is actually good for a couple of reasons, because it allows for good cleaning underneath the part. But that is just something that happens, something to keep in mind.
What about solder mask? Is that critical on part design? Like I know sometimes with very, very small BGAs, we'll use a non-solder mask defined pad, but pretty much everything else, it's a solder mask defined pad.
Yeah, so that's a good point. So, and we don't have a good graphic for this, but there is a lot of stuff online. If you look up solder mask defined pad or copper defined pad, it's important to see how solder mask can affect and prevent solder from flowing, so that you can see the difference between basically this G height here. So you can see on this image that G is that thickness of the solder fillet. If you have a solder mask defined pad, that G technically will be slightly higher versus a copper defined pad, where that fillet could potentially flow out to the sides of the copper pad itself. Most of these are not inspectable. However, they do affect the manufacturability, specifically during the reflow process, especially with really, really, really small parts. You could end up with a lot of shorts or even opens because of it.
Yeah, we just had that was actually a user question. The same user just sent a second one. Is there an industry standard for solder pad design? And the answer is yes. You should start with IPC 7351. That's certainly not the only one. Like covering thermal pads is another one. There's stuff out there, and I'm not good at repeating them off the top of my head, but if you want to shoot an email to mhughes@aapcb.com, I have references for all that for you, Henry. So, all right.
Good question, though.
Yeah. Oh, he's got great questions. Shane, sir.
Still here.
Henry just asked about, coming up with these pad sizes. Is there an industry standard for those things? And I did tell him, IPC 7351, but maybe now, since it's the next slide anyway, it's a great time for you to talk about it.
Yeah, let's talk about that and overhang conditions. So all of your side terminated and leaded components have a bit of flexibility in the land pattern design that you need to pick. Some people can kind of know this just from experience, but IPC 7351 basically provides 3 land pattern conditions for us to talk about today. There's the minimum or least, the nominal, and then maximum or the most. In the most condition, which you see on the left side of your screen, I'm making sure that I'm not looking at that backwards. Hopefully that's right. Yep. On the left side of your screen, here your part's going to have plenty of extra copper. It can be easily placed by a machine or hand in a lot of cases, and rework is pretty easy using that land pattern. Nominal in the middle, it's going to be a bit less copper, smaller courtyard, as Sebastian was talking about earlier. These can still be inspected and reworked easy enough. And then finally, the minimum or least land protrusion there on the right. And on this condition, things start to get pretty tight. So any of these will work. And so we're going to build on this conversation. Any of these will work. You'll just see that as you go more towards the minimum, there's going to be a little less room for inspection and very little room for rework.
Okay.
The dense stuff.
Yeah. So, okay. So let me go back one slide, just because I just want to make sure I have this clear as an engineer. So there are recommendations, but there's no one right land pad size. There's options, right?
Yeah, so I can kind of talk to that. There are good reasons to do any one of these. We're always going to recommend that you follow whatever whatever the manufacturer recommends. But if you have a very dense board and you, again, are worried about those courtyards, then you're going to want to design with minimal land protrusion in mind. There are also additional standards that maybe you have to meet UL or anything else that's out there that kind of requires you to keep in mind how close your pads are and how much extra space and how close it is to ground, to other signal lines, so on and so forth. So this is just kind of like a general guide and a rule, or more of a guide than a rule, to keep in mind. You can modify and work around some of this information, which we'll get into. It's just you may start to run into issues with it.
So the critical thing then isn't necessarily the copper, but the fact that the copper then leads to a proper solder fillet and passing IPC 610A or A610 inspection.
Correct. Yes. Yep.
Okay.
End goal.
All right. So this is just a step to get to the end goal. Got it.
Well, so just see on this screen, what I'll kind of introduce the idea here is, well, I talked earlier about my customer, Michael Drake. And what happened when we started talking about our options, basically we wondered if we would be able to combine any of these land patterns that we just talked about. And if so, how many could we pile on top of one another? And for me, theoretically, it was fun just to have the conversation. No harm in just throwing ideas against the wall. As you see on this slide here, there's not a lot of difference between any two package sizes that are just one part size from each other. So we're illustrating here, you'll see an 0603 on the nominal land pattern, and an 0805 on a minimal land pattern. And then by looking at this, you can easily see the 0805 land pattern, that the 0603 package or the 0805 could be placed on this footprint as we combine those on top of one another. Here at Advanced Assembly, and we've been doing this for years, regularly with customers. For instance, we might tell an engineer that on their board they've designed their board with the footprint for an 0805, but they sent us an 0603 part. Generally, what we would tell them at that point is, hey, if we can place this, it's not optimal, but it is placeable. And so what we're going to do today is we're going to show you how to potentially give yourself even more options than just the parts that are one size from each other.
All right. So what you're saying then is, like, for here, we've got kind of a stepped rectangular land pattern that we could put a small part in it or a big part on it. And I guess what you guys did there was you made an image of kind of like a transparent big part and then an opaque small part. So either one's going to fit just fine is what you're telling me.
Well, that was our idea. That was in theory, that's what we discussed. He designed the board and helped us design the footprint onto the board, and then sent it over to us. At this point, way back then, we didn't know if it was going to work or not. But yeah, in theory, what you see on the screen is what we were about to attempt to test here in-house.
So is this just capacitors, or is this capacitors, resistors, diodes, inductor, anything that's got a 2-lead rectangular pattern you're telling me will work?
I'll tell you that most of that will work. And Sebastian can kind of go into the details of the different components that we tried this with here in-house. But there's a host of parts that it'll work with for sure.
Cool. I'm excited.
Segue.
And scene.
So yeah, we just started stacking land patterns on top of one another. And here you can see how we quickly realized that this just might work out to allow multiple size parts to be placed on the same land patterns.
So all you do to make these is just combine the copper shapes. That's it.
Simple as that.
Wow. Okay. That's not hard.
One would think.
Oh, I'll make it hard. Don't worry about that.
That's part of being an engineer, is to make simple things difficult.
Yeah, and I try to describe things using the largest words possible, just to make it sound important.
It's just difficult to fit supercalifragilistic in a conversation, you know.
Well, that's why engineers have the confabulator. I forget.
Oh yeah. Yep.
All right. So what am I looking at here?
All right. So yeah, this was actually the board. We work with a board house. So we had them make like 500,000 of these. But this is a board we use to test how far mechanically and from an assembly standpoint we could go with this concept. And so what we did is we put these 6 packages, which you can see on the top: 0201, 0402, 0603, 0805, 1206, and 1210. And then as you go towards the bottom of this board, we started stacking these on top of each other. So for example, this second level, the 2X, contains 2 package sizes. The first one is an 0201 and an 0402. The second one is an 0402 and an 0603. And then so on and so forth, all the way down to the very bottom, where we have this monster of a LAN pattern that has the capability of sitting a 0402 all the way to a 1210. And so what we did was we built a bunch of these, a crazy amount, and then we pasted them using different volumes and like paste patterns based on the package type and everything else, and then placed some caps and resistors of varying size on each one of these, and basically just ran like 100 of these boards to see what was successful and what wasn't, if we were going to use some sort of methodology like this. How feasible was it to do something like this? And basically what we found out is it is totally feasible from a production standpoint to mechanically attach and electrically attach these passive components, these rectangular components, if you will, onto these with the correct paste patterns. That was an important caveat. If you have an 0402 and you're placing it on a 1210 pad, you must use a paste pattern that is the same shape and size as the entire LAN pattern. You cannot just put an 0402 amount of paste down. That did not result in a lot of good success. So yeah, that's basically what that is.
So give me a second to unpack this. So if I'm looking at this image and I go to the row that says 3X.
Correct.
That pattern on the far left is a combination of the 0201, the 0402, and the 0603.
Correct. Yep.
And let's say I put a part there. No matter what package size I choose, I have to paste that whole pad as though it's the biggest one, the 0603. Yep. And then I probably also have to use the biggest courtyard.
Correct. Yes.
Okay. And if we have any questions out there in TV land as we go through this, please ask them. We're happy to field them. All right. I think I get it.
Yep. And I kind of wish we had some pictures of some finished ones. I can fish those out maybe. But yeah, that's basically what we did.
Yeah. Finished ones would be cool to look at too. We'll have to look at it. What the heck do we have going on here?
Well, so getting the boards, getting the parts placed on the boards was the first step. But as we've talked about, the different component sizes, some of them are really close to one another, and what Sebastian was showing you there, that some of them are in the 0201 to the 1210. That's a pretty big jump. And so there is some caution that has to be taken when using this approach, for starters, because electrically, some things might not be compatible. And so the way I best understand this is to go back to my hobby, Mark, that you were talking about earlier. Mark mentioned that I love to climb mountains. So I'll reference that. So I spent a lot of time in the backcountry, and before I ever head to the high altitude backcountry, I got to prepare myself in several ways. And one is to be physically ready. And the second one is just to be informed. So I look at a topographical map quite often. And when I see contour lines all bunched up really close together, I know that I'm going to have a rough time, and I need to be really just proceed with caution. Sometimes I even got to change the direction, change the route that I'm going to take. But that's just how I relate to it. And so what you see that on this screen. There's spots where contour lines are all bunched up. And when that happens in the electrical world with electricity, large change in voltage over short distance, bad things can happen. So that's kind of what this is showing you, is just some areas to take extra precautions. And so I'll let Sebastian, I'll let you kind of wrap us up and talk about some of these conditions and things we want to do or things we want to be aware of, and then things you want to do to kind of avoid some of these areas.
Yeah, so I think it's important whenever you're looking at using a flexible footprint. Obviously, we tested the mechanical viability and how capable an assembly house is of producing good results with some of these things, but we took it to the extreme. We took trying to place an 0402 on a 1210 area, or a 1210 with an 0402 pad attached to it as well. And these are some of the risks with doing or applying some of these techniques to some designs. There's not like one design that this works well for. It's going to really depend on how much voltage you're putting it in and what type of part it is. Resistors are probably the least likely to have issues with these types of designs. But for example, there are limits on trying to find a certain capacitance at an 0201 size. So those are definitely things you want to take into account whenever you're trying to use a flexible footprint. Shane touched on it earlier, but it's also kind of a good thing to stay within one package size of whatever is nominal for your design. Don't try and put 0201s on a 1210 package. Although you can, you probably should not. If you have something, for example, that is less critical and it's very low voltage, there's very low risk in these being a real issue, then yeah, by all means, go for it, expand it out. But if you've got something critical to life or something like that, just make sure you're vetting out your design so that you're not introducing a design-related issue later on.
All right. Well, that is interesting. So just to kind of summarize, to make these things, these flexible footprints, all you really have to do is just stack land pads, one on top of another. And then when you paste for the overall, the superimposed pad size, regardless of what part you use, and use the larger footprint.
Yep.
Okay. All right.
And we're always available for questions.
And we are available for questions. Well, let's take a couple now. It's been kind of quiet, but maybe that's just because we explained everything so well that nobody misunderstood anything. What do you think?
I don't think anyone's ever told me that.
No, never for me either. So let's take a minute and ask some questions. And if not, I will ask a couple questions. Oh, okay. This one's from Norman Tracy, and it might be one that I would field. In Altium Designer, stacking pads like this would result in a 2-contact part in the schematic trying to match a part with 6 or 8 pads on the PCB side. Also, I would expect the design rule check to go a little crazy trying to sort it out. Creating the copper and solder mask patterns on the PCB dual, does it have 6 or 8 pads, or do you create the shape as one pad? Norman, you would need to create your own pads. Yep. You would need to create one that has the shape of 2 or maybe even 3. Probably 3 would be the most that you would want to play with. So you would be creating custom patterns. You can't actually stack one part on top of another, or you're right, it's gonna give you design rule errors all over the place. So you have to make your own. We chose not to not to provide footprints for this just because we don't have available seats for all of the different design libraries like Altium and OrCAD or PAD, whatever it is. We just figured, this is kind of simple enough. We would just let people do their own. So I hope that helps. And if not, please feel free to follow up on your question.
Good question, though.
Yeah, no, it's an excellent question, and probably something we should make a slide on.
Yeah, it's actually a really good point.
Yeah, I think that's good. Okay, what other questions do we have out there in TV land? In your testing for solder pass size, what kind of paste were you using? Was it lead-free? We typically see that lead-free paste does not flow as much as tin lead, at least on ENIG. So we've got multiple questions we can pull out of this. What kind of plating did you test? And do you recommend? What kind of solder? Lead-free, clean, or no clean flux? Even ball size, maybe. Can you tell us any about that, or do you need to research that?
Yeah, so we would feel confident, my assembly house specifically. This is a great question for other assembly houses. Our lead-free mix that we use for our paste, we typically do not see those same types of issues. We have a pretty well vetted out reflow and pasting process. If we do have something that is a concern, we also use a My 600 paste printer, so we can modify that on the fly so that it can be as optimal as possible when we're running. We did paste these with both leaded and lead-free. It was with no clean. Let's see, we tested these with Hazel. We did not test with ENIG, but I do suspect that at least with our paste, we would get similar results. Yeah, I would say as long as you're meeting that same criteria of your paste pad being the same size as your land pad, you should be okay.
And something else, Philip, if you are pasting at home and not using an assembly house, because some people do, or you've got your assembly inside the thing, make sure you're using fresh flux. It goes bad over time. We get new flux in the machine daily, or new solder paste that has flux in it in the machine daily. So if you've got something that you've been sitting on 6, 9, 18 months, that might be a reason you're getting less than optimal solder flowing. So just a thought. I might not be relevant at all, but just passing that at all. All right, we've got a question. I don't know if we're going to be able to answer this, but the question is, can this technique be used with RF bypassing, where one uses multiple vias to ground on a bypass capacitor? I would say yes and no and yes. Never put the bypass vias in the pad because the solder will wick into the hole. There are some things you can do to mitigate that, but really what you want to do is put the via off to the right and do via tinting, or at the very least create a solder dam with a web that's, it depends on the assembly house. Up north, we can do a minimum web of 4 mils. Down south in Huntington Beach, we can do a minimum solder web of 3 mils. But you don't want to leave an opening to let the solder find metal, a continuous path of metal, and make it into that hole. The other thing you can do is use a really small via. If you can do that without screwing up your impedance, well, I guess it shouldn't matter for a bypass cap. Sebastian, how else can we keep via in pad and via near pad from wicking the solder away from the pad?
Yeah, as long as the via in pad is capped, it shouldn't be any issue. It's important to understand the difference between capping a via and tenting it. So tenting it is covering a via with solder mask. Capping it is basically covering it with copper, basically. So if you cap them like that, it would be perfectly fine. There would be no issues with that as far as assembly goes. And I think one of our slides, I think the picture of the test board actually has something similar to what you were talking about in the beginning there about your solder webbing. Yep.
Here. Oh, did we not do that?
We can. This was testing only. Okay. And I do believe there actually is solder mask in between those. So.
Oh, if there is, it's not much, but I guess a 4 mil line wouldn't necessarily show up very well in a picture. So, all right. I hope that answers your question. So can it be used? Yes, but you do not want to leave open vias in or near a pad ever. Otherwise, Sebastian will yell at you. And he yells really loud. It's kind of scary.
Yeah, I will contact a customer.
Any other questions? Or did you guys find this remotely useful for your designs? We hope. I mean, nothing. Okay. Well,
Cool, not cool.
Let's wrap up then with the contest. So our contest for you is this. If you make a flexible footprint pattern and you add some sort of module to it, it could be Arduino, Raspberry Pi Zero wireless, a Raspberry Pi Pico, the 2040s, anything. We don't really care what. Any module, a flexible footprint, and then add some input and output, whatever that might be, a switch, a LED, whatever, and get that to us by August 31st at midnight, you win the chance for us to make your board. So this might be a fun one if you guys want to make some sense or something at home. We'd be happy to make these boards for you. And if you don't win the contest, you can get free swag. So everybody's a winner. Everybody's a winner. All right, we do have a little bit of feedback for our presenters that I would like to share. Thanks for the idea. I'm converting a 20-year-old design to surface mount, and this will help with the current part shortages. This was worth my time for sure. So Sebastian, Shane, thank you for working so hard on this. Really, the idea itself is not that crazy, but what really is useful for me as an engineer is knowing that you've tested it, right? Knowing that you've gone through and done some amount of verification is really the valuable part in this, because I probably wouldn't want to or even be able to afford to pay the R&D to do this on my own as a design engineer. So that's really valuable, guys. I appreciate it. All right, with that, thank you so much. This webinar has been recorded. It will be available on our blog sites at aapcb.com/blog. It'll be available on our YouTube, which is youtube.com/channel/ I think it's Advanced Assembly. And if you have any other questions, we would really, really like you to reach out and ask them. We're happy to answer them for you.
Mark, you got to read the last comment from Norman for Sebastian. It's spot on. Great way to in the call today.
Okay, I'll read it. Or do you want to read it, Sebastian?
Yeah, sure. I'll read it.
Do you see it?
Yep. Contacting customer with VN pad to yell at is nice. The typical response is to let it slide, and when the PCBA is broke, commenting, "Wow, it stinks to be you," I guess.
Yeah, it can really just stop, especially if you do it in a thermal pad, it can just stop production dead. So anything you guys want to say before we go?
I just thank everybody for your time today. And if you have questions, feel free to shoot us emails and let us look at some designs for you and see what we can do to help you guys out. This is it's fun for us. We love to do it. So anything we can do to help you and answer your questions, we'd be more than happy to.
Sebastian?
Yeah, look, he's a sales guy. I let him talk.
All right. Well, Sebastian would like to thank all of you for sitting there listening to him as well. It's been a blast.
Yeah, listen to me just drone on and on.
All right, everyone. Have a great rest of your day, and we'll see you at the next our next webinar. Take care.